Now let's do the exact same example using the other method, the equivalent annual NPV method. So remember, we've got two different projects, a 2-year and a 3-year with two different NPVs, 624 and 816. What we want to do is convert them into an annual annuity amount, and then when they're annual, we can compare the two. And what we need to do is we need to use the PV of annuity formula to do this. So this formula is as follows. This is the ordinary annuity, where the payments are at the end of the year. So the present value of an annuity is equal to the annual annuity amount multiplied by 1 minus 1 over 1 plus k to the power of n divided by k, where k is a discount rate and n is the number of periods. So if we do project A, okay, the PV of the annuity is equal to the net present value, the $624. K is equal to 0.15 and N is equal to 2 years. So if we plug all of that in, we get the following. So $624 is equal to the annual annuity multiplied by 1 minus 1 over 1.15 to the power of 2 divided by 0.15. And if we rearrange, the annual annuity is going to be the $624 net present value divided by 1 minus 1 over 1.15 to the power of 2 divided by 0.15. All of that in a bracket. So we get the annual annuity amount, in this case, is $384 per year. So that's the equivalent of having an NPV of $384 per year, project A. Project C, different timeline, but same formula. K is still going to be 15%. N is now 3, and PV is 816. So if we plug that in, we get 816 is equal to the annual annuity times 1 minus 1 over 1.15 to the power of 3 this time, because it's a 3-year project. And if I solve for that, I get an annual annuity of $357 per year. And again, you can see that project A is better. So both methods take a different approach at it, but what they're trying to do is equalize the timeline for the comparison.